live in northern New York State, where it gets pretty cold. You've maybe heard of the weather reports.
You mean no chainsaw?
No chainsaw, yeah, so bow saw or bigger trees with a two-person crosscut saw and axe. And so as I'm getting older especially, I'd like to get more heat for less effort. And rocket stoves have just convinced me, for all the time I've spent with fire, that it'll be hard to improve on naturally aspirated fire technology beyond rocket stoves. I'll be really curious to see if that comes into existence. So that's a very brief sketch of my background. I'm really grateful to the Aprovecho folks. While they don't pop up on most internet searches right at the top around rocket stoves, they are the folks who really pioneered them to get them to mostly women in the developing countries who had disproportionate amounts of lung disease tending open smoky fires. And so I'm so glad they did the calculations, had the sensors, crunched the numbers. They've really got that wealth of information that could allow you to take the basic technology and apply it to your particular circumstance if it's something other than a mass heater. So that's my real interest in it, is learning how to make highly efficient fire and then doing all kinds of life-affirming things with it. Or she sees a connection between rocket stoves and a top-down fire. And I'll say two things about this fire for starters. One is that after building a couple fires in this firebox, I've made the firebox smaller because almost always commercial stoves, the fireboxes, I believe, are too big. It's almost impossible to have a small, highly efficient fire in a big, cold space. And the other fundamental flaw, I would say design flaw, with a commercial wood stove is that whether they've got baffles and blowers, they're trying to get the heat out of the firebox.
Right.
And if you want to burn highest efficiency, you want the fire to stay really hot. You don't want to get any heat out of it while it's burning, because then you're going to lose the efficiency of combustion. So, you know, and the rocket stoves are fundamentally designed so that the combustion happens high efficiently in one spot, and then you put it into your mass heater or your water heater or your cooktop or whatever. So it's a bit of a struggle. I made the firebox smaller, and at the very least we can burn a top-down fire. You can burn a top-down fire in any stove.
And fireplace.
Or a fireplace, and fireplaces are pretty inefficient. But the common thread between this and a rocket stove, which because of insurance purposes we're not going to do that, is that in principle the heat gasifies the fuel that's in the wood. The primary BTUs in wood is in the gases that will come out with heat. And so the heat gasifies the fuel, and then if you have the proper airflow, that gas has to go through the hottest part of the fire, which is where the flame is. So building from the top down, you have the opportunity for the gas to rise up through there. Now this is a terrible conformation for a firebox for that to work really well, but it's going to work better than kindling it on the bottom, adding things on top, which will cause the initial gases to go right up the chimney.
And you'll see a box full of smoke as a result.
Yeah, and one of the things about rocket stoves that's probably obvious to you by now is that it meters the wood. It turns the fire into a metered, measured thing.
So, but getting back to your question about the rocket stove,
You're not filling a firebox full of wood and lighting it like you are here.
the wood is external to the stove and
Right.
it's fed in, so, I mean, you
Oh,
control.
so by metering, you mean the amount of wood you're putting into it?
Yeah.
Well, there's metering, and this is a variation. This is a crude estimate of metering that increases the efficiency of a standard, poorly designed,
Right.
aesthetically pleasing stove.
And once-
To a certain extent, even though we've got a firebox full of wood, you can see it's sort of metering itself in that if we had kindled it and put that much wood on top, the whole thing would have started to get consumed. And think about it. There's a 6-inch opening going out. There's no more of an opening going in, and you've got this huge space. How can that fire burn? How can enough air get in and out? It's not, I don't believe it's possible, so I'm just marveling at how inefficient 90% of what's commercially available is. And I'm glad you're all here to build your own rocket stoves and make something efficient. Yahoo!
So
Thank
you're
you.
saying it's like it's not breathing, kind of?
You can't get
Right.
enough air for the fuel load. It's all the relationship between the fuel, the airflow, the heat that's available to it all, having all those things happen simultaneously with an ever-changing, and we do have this rocket core, and we'll really be able to see how remarkably different.
I think it's like that. You're trying to get the right combination for something that's efficient. And I'd like to encourage you to adopt as an answer to what is efficient, look at the smoke.
Okay.
That's one of the best. Look at what's coming out of your exhaust.
Because that's the fuel that's not getting burned. If there's smoke, then you don't have the heat. That's the gases that turn into flame. All right, here we go. Again. And so, with Doug's help, we have a wonderful empirical experiment available to us because this part slides, okay? And there's cutouts on either end.
So you can experiment.
So we can, so we're gonna, before we set this in Cobb, we're gonna experiment and see if there's any difference. I'm going to predict that the way it's set up now is going to be just fine with this literally half the size of where the wood goes in, and I'll talk about that
Wouldn't
later.
it have some help somewhat to create a draft through here so
You're
it
gonna
doesn't
get higher
smoke
velocity.
there? Yeah, because this creates a venturi right here. Yep.
Yeah, and if it's too small, it's not going to
Yeah.
allow the
Yeah.
fire to
What's a
go.
Venturi?
So,
It creates a negative pressure, so it draws things in.
Yeah, it's like
It's a constriction in a
yeah,
pipe,
it's like
which is where you have your
if
6-inch
you
pipe.
close your
with
your
So
mouth
that's what
and,
pulls it,
and
makes
suck
it a
the
rocket.
same, it's really there, it's
Is that
really
what you're
moving
talking
through there
about?
Here-
faster.
Here's the
Because
thing,
it's
a
smaller
venturi
space.
is, you've got that much air coming in,
Yep.
then it goes through a pipe that's that big. So it's gotta move faster to get the same amount of air that's going through.
And the fire never
Rarely.
sneaks up this stick.
if I'm not paying attention to it, and the sticks are sort of stuck here, and then the fire starts coming up, sure. Yeah, and that's where there's an attention component to all this. But as long as I pay attention to it, even being twice as high gives it that chimney effect, and it all draws the way that you want it to.
Well, how do you heat this flue to start out with to get the draw started?
The chimney effect, just having
Just that's enough?
higher, it's amazing, and
Yeah.
you'll see when there's a number of ways that I'm hoping to demonstrate this. Even with the little stove, the Cobb stove that's under the awning, there's barely this much difference between the intake and the exhaust. It works fine, and what we'll see is if we put a piece of smoke pipe over that, it'll just
Yeah.
the chimney effect is amazing.
Can somebody here describe the chimney effect in scientific terms, or, what is actually happening?
Just what
Magic.
Magic!
Magic, that works for me.
The lateral flow is
Okay, but okay.
increased.
Like,
before there's a pressure differential. So
Say
you're-
again?
could
You're,
you just
you're
Say that
increasing the length of the concentrated flow, right? So instead of the air just going out into space, you're increasing the length of it, so that increases the draw on the source. So if it was really long, you'd have an incredible draw.
Except for
Suck
resistance.
the pieces of wood in.
It can only be so long, and then there's resistance within it.
So your fastest flow is going to be inside the pipe, not against the walls, right? Because
Okay.
it's like
Oh, yeah, okay.
rubbing up
I
against
get
the
it,
walls.
yeah.
So that's the fastest is in the center. If you have a long enough pipe, you lose even that.
Over time.
So you get enough
Okay,
friction,
different.
and eventually it feels like it's clogged.
So on the most basic rocket stoves I've looked at, you make it in a 5-gallon bucket with some sewer pipe to mold, and you
Pocket rockets. Is that
Well,
what you're
they're not
talking about?
running about this big, but yeah, I guess you call it that. Well, in that, they say that the diameter of the opening needs to be, the position of your stove needs to be so many inches relative to the diameter of your opening, like it was 4 inches and 12 inches, or 3 inches and 9 inches. I mean, does that apply in this situation?
It sounds like you're talking about first a horizontal feed. One of the
Yeah, as
more-
opposed to the down.
Yeah, this is a downdraft,
Yeah,
down
it
feed
is,
design.
yeah,
If
okay.
you're looking on YouTube, this is often referred to as a J
Okay.
J construction.
Yeah, whereas I think the original rocket stoves have little horizontal feed, and you're
That's right.
constantly pushing it in. And I can't say anything specific about the dimensions, except the dimensions are important, and I'm sure somebody has formulas. I don't.
Is the advantage of the J just that it's easier?
It's easier,
Self-heating.
and it's
Yeah.
self-metering.
Yes.
It's
As
safer.
long as think about it, the fires, you've got these sticks standing up in here.
Even that high.
Oh yeah, yeah, and the fire is happening right here.
Yeah.
As the ends of the sticks burn, they drop down.
Yeah.
In principle, it doesn't quite always work that way, so it meters it, and that's it's self-metering. If you could have the same efficiency with a horizontal feed, and you're constantly pushing it into the combustion zone. Well, it's not obvious. This has a port here, opening,
Okay.
horizontal opening, for ease of setting the tinder kindling pile, as opposed to doing it down like this, for ease of clean out. And sure, the way we'll start it is we'll cover this, we'll light that kindling pile, it'll draw like crazy, because here too the air is sort of focused on the fuel, and then we will, once that's going well, plug this, be putting our sticks in.
I've got an idea of things to do, but they'd be 10 times better if I did them with you. So come over here and we'll make them happen, with a bit of inspirational collaboration. Let's get together. Yeah, with a little bit of effort we can make community. Let's get together. Let's get together. Oh, 1 and 1 has more than 2 functions. We need to make the connection, shed the illusion of separation.